Now that we've been able to graph lines and seen some of the shortcuts, we're going to see here how we're going to take lines or information about lines, points, slope, whatever, and make the equations. And we're going to see some really neat relationships here. So as a reminder, we're going to go over here and kind of do the shortcut. If y is by itself, most famous thing we've ever heard is y equals mx plus b. You hear that all the time. People say it. What does it mean? Well, the slope is right there. And here is the y-intercept. That's why it's called the slope-intercept form of a line. Now for standard form, it looks like this. ax plus by equals c. And here the shortcut, some people like to solve this for y up here so they can see what the slope is, but the slope is the opposite of a over b. And then a third one that isn't as often used but is certainly handy to know is called the point slope form of a line. And this one actually comes from, let's do a little bit of derivation here, comes from when you have the slope is always y2 minus y1 over x2 minus x1. Well, if you know one of these and you don't know the other point, it's just a generic xy point, but you know the slope, you can times by this. I'll show you what I mean. Let's say you didn't know this point and it was just a generic y, generic x. You times it up there and you get x minus x1 times m equals y minus y1. Remember, y1 is a point that we know, y1, x1, x1, y1, and we know the slope, but we don't know this other y. So this, we write it kind of like this. I'll show you how this works. That y minus y1, that's something we know, slope x minus x1. And we'll show you how that works in just a minute. So let's go through a couple of these. If I give you the line y equals 5/8 x plus 4, you can say, hey, I know what the slope is. It's 5/8. And it goes through the point 0, 4. Very nice. Now, what if we wanted to go backwards? And I said, what if I had a slope of negative 2/3 and it went through the point 0, 7? Is that enough information to give me the equation of the line? And certainly it is. You take this and you say, well, it's got to look like this. Y equals negative 2/3 x. Here's the y-intercept, 0, 7, so we stick it right there. And we have it. Gets a little bit more difficult when we say, what about y slope is 5 and it goes through the point 1, 4. Notice in this case we're not given the y-intercept. That means the equation of the line looks like y equals 5, that's the slope x, plus, well, we don't know what the intercept is, so it's this some number b right here. So let me draw that in a different color. And we're going to use the fact that 1, 4 is a point that is on this line to figure out what b is. 1 goes in for x, and 4 goes in for y, and we get this equation. 4 equals 5 times 1 plus b. Subtract 5 from both sides, and we know, hey, b has to be negative 1 for this point to work in that line. So that tells us that our equation must be y equals 5x. We already knew that part, but we didn't know the b, which we now know. And you can try it. This has slope 5, and 1, 4 will indeed work. Let's get a little tougher one. What about slope of, say, 3/8, and it goes through the point 5, 2? This is how it'll work. You have y equals 3/8 x plus, we don't know. So I'm going to put it in a different color because we don't know it just yet. And we stick in 5 for x and 2 for y. So we get 2 equals 3/8 times 5 is 15/8 plus b. Subtract 15/8 and we get 16/8, that's 2, minus 15/8, that's 1/8. B is 1/8. So that gives us our solution. We now know the part we already knew, 3/8 x plus 1/8, which is very interesting. From this information here, m equals 3/8 and 0.5 halves, we now have the equation of all the other points that are on that line. We could stick in x equals 8, x equals -2, x equals 0, x equals 15, and get its partner. We can do anything we want to with it now. So that is all on for slope-intercept. Slope-intercept form of the line. Now we're going to do the same thing, but we're going to do it with standard form, so you can see how that works. So here we're going to start off with the equation of line, 3x plus 8y equals 9. Slope, if you remember this shortcut, is this number over this number with an opposite going on here. Some people like to think of it as, and you get it into the slope-intercept, you subtract the 3x, that gives a negative, and then divide by 8. So the slope is a -3/8. And here's a nice point, 3, 0. Now, let's see if we can go backwards on something. What if the slope were -5/7? That would give us 5x plus a 7y. Notice this shortcut here, the a, that represents how much the y changes, but in the shortcut of the equation, it ends up being in front of the x. B represents the run in slope, or how much the x moves, but it turns out to be right in front of the y. That's an unusual connection. Kind of surprising for most people that the change in y turns out to be the number that multiplies x, but that is the case. Let's say we had this, so here we have -5/7, 5x plus 7y, because that negative's already taken care of. A is 5, B is 7, and let's say it goes through the point 2, 4. Now all we have to do is find this number over here that makes it work. This turns out to be a little bit easier than slope-intercept, because we stick a 2 in for x and we get the number 10. Stick 4 in for y and we get 7 times 4 is 28. 10 plus 28 must be 38. So this point, 2, 4, works in this equation and it has that slope. Let's try another one. Slope is a -3/8 and goes through the point 2, -4. Then we write the slope. Negative's already taken care of, so 3x. B is a +8. It's a plus 8y equals, and we stick a 2 in here, a -4 in there, and that's a -26. Let's try one more. Slope is +5/11, and it goes through the point 3, -5. That is 5x minus 11y. Notice how this sign is going to be opposite of the slope. That's what we have here, that the slope and this have opposite signs. So when the slope is positive, that has to be a negative in there. Equals, and then we take 3 and put it in there, 15. -5 in there, that's plus 55. So this is going to be a 70. Now we're going to take and do one of these where you can see the connection between these two. So we're going to start off, we're going to have slope +5/8, and it's going to go through the point 3, 1. Now we're going to do slope-intercept first. That's y equals 5/8 x plus some b that we don't know. Stick in 3 for x and 1 for y, and we get 1 equals 15/8 plus b. Subtract 15/8 from both sides, and we get b equals 8/8 minus 15/8 is a -7/8. So our equation is y equals 5/8 x minus 7/8. Now we're going to do the same thing with standard form. This is the same equation, 5x minus 8y. Remember, it's going to be the opposite sign, equals, and now if we stick these in, we get 15 minus 8 is 7. So we have 5x minus 8y equals 7. Now, just to see that we actually have the exact same line, we're going to take this equation right here and solve it for y. So we're going to subtract 5x from both sides. And that's a plus 7. And now we're going to divide by a negative 8. Negative 5. Okay, yeah, let's write that out. Negative 8, negative 8, negative 8. So we get positive 5/8 x minus 7/8. So it really doesn't matter whether it's in slope-intercept form or standard form, and soon we're going to see this point-slope form that's going to be pretty handy. They're all going to be the same thing, and being able to transfer between them is kind of important. If you had this one, you'd times through by 8, subtract the 5x over, and then usually standard form ends up with a being positive. That's not totally necessary, but you see that this could be a negative 5x plus 8y minus 7, and that would be the same thing. Okay, now we're going to teach you about this point-slope form. This is very handy to just get it on paper. So if the slope is a 3/8 and it goes through the point 2, 1, this is what you do. You do y minus, that's your y1. Here's your x1 and your y1. Y minus 1 equals m x minus 2, and you're done. You leave it like that, and it tells you here's a slope, and your point is 2, 1. And so it's easy to see, but it's not completely simplified. So I'm going to show you how this connects with slope-intercept. Just a minute, let's get one more example up here. Let's say I have a slope of negative 5/2, and it goes through the point 7, 3. In slope-intercept, it looks like this. Y minus the y value of the point we're given equals slope, negative 5/2, times x minus the x value of what we were given, which is 7. Now, here's going to be a little bit of cool connection, in my mind at least. I'm going to go and I'm going to use the slope-intercept form on this one and see what we end up with. We know it would be y equals 3/8 x plus b. We don't know what b is, so we stick it in. 1 equals 2 times 3/8 is 6/8 plus b, and subtract the 6/8 over. 8/8 minus 6/8 is 2/8, which is 1/4. So we get y equals 3/8 x plus 1/4. That's what it looks like in slope-intercept. And this right here, watch what happens if we simplify this. Y equals, well, y, yeah, 3/8 x minus 6/8, and then we add this one over to this other side, and we get negative 6/8 plus 8/8 is positive 2/8. Amazing! This next one we're going to do, I'm going to do this exact same equation of the line, and I'm going to do it in standard form, simplify it down to slope-intercept, and we'll simplify this guy to slope-intercept, and it will be the same thing. So we have slope is negative 5/2, that's 5x plus 2y. I'm doing standard form right now. Equals, stick 7 in, that's 35. 3 in for y gives me a 6. 35 plus 6 is a 41. So solve for y, and I get y equals, subtract 5x over there, and when I divide by 2, I get that. So let's simplify this and see what happens. Y equals negative 5/2 x plus 35/2, and I'm going to add 3. Okay, so that's, I've just distributed that through and added 3 to both sides of the equation. So now I get y equals negative 5/2 x. 35/2 plus 6/2 is 41/2. It's a stinking miracle. This that all represent the exact same equation of a line. So we have